everyone, please raise your hands. Let me see how many active attendees in this session. Please raise your hands. $33. So there are 53 attendees. I can see 35. Okay, please lower your hands. Students, then and there, I may ask you questions to make it interactive. Don't feel bad. Please lower your hands. Can you see my screen? Can you see my screen?
Yes, ma'am.
Yes, ma'am.
Yeah, thank you. Thanks for answering. Students, final year students, you are just hesitating to interact with the teacher. Okay, anyway, I don't know the reason. Okay, so the last session we discussed about building abstractions with procedures. So in Lisp language, that too particularly in the schema dialect, how to define a procedure. The procedures are very helpful for defining, implementing a logic, right? So with respect to that, we have understood that define keyword. With the help of a define keyword, you can define a procedure or define a name. Name in the sense as a variable, right? So by looking at this particular syntax, you can know how to define a procedure, how to define a variables. That means, sorry, names, arguments, formal arguments, and how to define the body section. Okay, so throughout, if you look at, there are bracket, 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 bracket. Okay, all things are there. Okay, carefully you have to close. That is the point. Awesome. Okay. So now, so we have defined, we discussed some of the procedures, okay, called the square and the sum of squares. Sum of squares are built on top of a square function. And we also defined some function called the f. F is on top of sum of squares. So that means f is going to make use of sum of squares as well as square function. Right. So in this way, we have built higher abstractions, right? So F is in the higher level of abstraction, which hides the details of sum of squares and square functions, right? So by knowing everything, and we also have come across some of the control structures. Some of it is not a control structure. Some of the predicates, okay, like condition. Okay, how to implement a condition? Without a condition, we can't write the whole logic by using only the procedures and calling the procedures recursively. We can't perform, right? So sometimes we have to break the recursion and we have to come out to return the value. So we had this cond keyword, and by which we can specify the predicates and expressions. So the predicates is returning true, then the value of predicate P1 or P2. P1 is considered it is true, the E1 will be evaluated, and it does not imply that you can have a single expression. You can also have a continuous expression, a sequence of expressions you can have here. That is the fantastic feature of cont. So for a given condition, you can have a sequence of expressions to be executed. Okay, so if you look at, there are predicates, the n number of predicates, and one-to-one mapping, that is expressions are mapped to predicates. Right. So, and always these predicates are going to return you hash t or hash f. And this hash t and hash f is interpreted as a true and false, right? So another keyword what we have discussed is if statement, okay, if procedure. And before that, if you look at, there are two versions of defining absolute, finding absolute value of x, or implementing the logic of the function absolute of x, right? So, And if you look at this one, else is also possible. The syntax else is also possible. In the previous case, I have shown you without else, but else also possible. So when the else will be executed, if all the predicates are returning false, okay, all the predicates are returning false, then the else will be executed, right? So this is like if statement. If the condition, then execute the consequent, else execute the alternate. So if you look at this one, x is less than 0, return minus x, else return x, right? So here, if you compare the cond and if, what is the difference? The difference is consequent. If you say that should be a single expression, alternate, if you say it should be a single expression, you can't have a multiple expressions, but in a cond we can have it, right? So with this idea, let's move on to our session, today's session. So now, how to use the conditional expressions? How to use the conditional expressions in the predicates? Right? Predicate, in the sense it will return you true or false, we know. And the predicates is a combination of relational operators, less than, greater than, equal, etc. And now we can also use the logical operators like and. Okay, so how to write the logical operator and? So and then expression 1 to expression n. This is the syntax, right? So what happens? How the language is interpreting? Okay, may I ask you, what is the, when this predicate is going to return you true? Any one of you? It may be a stupid question, but I would like to answer for this. When this predicate will be returning true?
When no expressions
when all the expressions are returning true. Yeah, correct. Yes. So this is our human interpretation. But now, if you go inside the interpreter, the Lisp interpreter, how it is going to evaluate optimally, right? So always we have to reduce the computation time, right? So now, how the interpreter will be evaluating and returning the answer true or false? Okay, so what is the optimization algorithm we can apply while evaluating this predicate? Can you tell me, for example, there are 10 expressions available. Each and every expression can return you true or false, right? So how will you optimally work on this? If any one of the expression returns false, immediately come out and return false, right? You no need to evaluate the further expressions. Okay, consider you have 10 expressions, right? In the third expression, while evaluating the third expression, it is going to give you false. You no need of evaluating E4 onwards to E10, right? So this is the way optimally we can build the compiler or interpreter, right? So our schema dialect is also going to work on this fashion. What it does is it is evaluating all the expression from left to right. It starts from E1, it is going on till En. So while the expression is evaluated, it knows what is the value, true or false, right? So as soon as some expression returns false, then immediately the whole expression stops and it is going to return you false. So that is a fantastic feature of schema, the Lisp. Okay, so this is a way optimally you can write the expression, return the expression. Okay, I hope you understood, right? For the given 10 expression, you no need to evaluate each and every 10 expressions. Okay, so as soon as some expressions are returning false, immediately the whole thing can be winded up by returning false. Right? So this is the way the Lisp interpreter is also working, and we are also thinking that is it is a very good optimized algorithm the interpreter is running inside. Okay, so that is what. So now consider all the E's or all the expressions are true. All the expressions are true. What will happen? What will be returned? It will return the last expression. Yeah, so everything is true, so it will return the value of the last expression. It will not return E1 and E2. It will not perform the operation. true and true and true and true, it will not evaluate, and it will return the the value of last expression. So it knows that individually it is evaluating each and every expression, and each expression's value is true, right? So which one will be evaluated? It will not do the operation of true and true and true and true and true n times. It will not perform. Okay, so immediately it will return the value of the last expression. Why? Because the last expression is true. So everything is true, last expression also true. So if you perform AND operation, the value is true. So the list interpreter is going to return you the value of the last expression. Okay, so these are all the internal mechanisms we are learning, right? So I can understand given and the expressions, I can understand very well, right, how the language is going to operate and what will be the value. But internally, if you look at how the interpreter is going to work on, okay, that is very, very important, as we are all computer engineers. Okay, so provided, let's look at R. So R E1 to En. What is your optimal algorithm for this? How will you evaluate? What is your expectation that the Lisp interpreter has to behave or will be behaving like? Anyone of you, please?
Continue until a true occurs, and once a true occurs, return true.
Yes, very good, awesome answer. So now this interpreter, what it does is it evaluates expressions E1, E2, etc. And as soon as any one of the expression is true, it will come out. It will come out and say it is true. Right. So that is the optimal way of returning the answer in a quick time. Right. So the valuations are executed from left to right. If any one of the expression is going to return you true, the whole expression returns that value, that expression value, that is a true. Okay, this is the logic. So the rest of the expressions are not at all evaluated. Okay, so from the first expression itself it is giving, and if you have 100 expressions, 99 expressions are not going to be evaluated, right? Okay. So in order to evaluate false, so when this one will be giving a false value. So finally it is going to return you false when it will be. So in this case, all the expressions are evaluated till the last, and it checks anyone is giving a false. Sorry, everything is giving a false. Then it will return you false. Okay, right. So now, and I would like to ask a question here. By seeing the syntax, this is R, okay, there is a bracket, R expression, then close a bracket. And is it a similar thing like, for example, I have a plus AB, where plus is called as a procedure, right? In the Lisp language, the plus minus, all the primitive operators are called as a procedures. Right, for each and every operator you have the equivalent machine instructions, right? So now can you say this R is a procedure? And if you say and is a procedure, what is your answer?
No.
No. Why? Because the thing is, if you apply plus to A, B, C, D, E, what happens? The plus procedure will be operating on all the arguments. But now, by looking at the characteristics of Lisp, and even up to En are arguments considered, but all the arguments has to be considered, right, for the valuation of the and R. It is not happening, right? So in the case of and, so something is giving a false, it will stop executing other things, right? So some other arguments are skipped out. All the arguments are not taken, and it is useful. It is used for evaluating an expression, right? So that's why I can say and are not the procedures. It's a special form. I can say it is a special form. Okay, so let's look at not expression. So what the Lisp interpreter will do by seeing a not, and it will evaluate the expression. If it is returning the value of t is e is true, it will return false, the ulta case. If it is false, it will return true. Okay, fine. Now tell me, not is a procedure? Is not is a procedure? Procedure means all the arguments has to be applied, used by the procedure. right? So now not and a expression, this expression is used by the not. So not is a procedure. Okay, understand? So I say that and are not a procedure because all the expressions are not considered for evaluating the expression. But not, I can definitely say there is only one argument, and not is a procedure after all. So not has to work on the procedure, work on the argument, the given argument. It has to evaluate. It has to understand what is the resultant value of the expression. Okay, so I hope you understood, right? So shall I call someone to conclude about whether and or not, how it is performing, whether it is a optimal execution, the Lisp is following a optimal execution or not? Lisp is using an optimally executing and or? Yes or no? Yes or no? Students, are you there?
Yes, ma'am.
Only one student is answering every time. Let's see. Okay. Now I will randomly call you to define a procedure. There is a requirement like 5 less than x less than 10. What is the interpretation? X is greater than 5, but x is less than 10. Can you write a procedure to implement this? Can you write a procedure to implement this in the Lisp language? How to define a procedure by using the define keyword and then procedure name. You take some name and how will you write a procedure for this expression? Mathematically, I say 5 less than x less than 10. And I know the meaning, but in a Lisp, I have to write a procedure. Any one of you? Are you there? You can just write in your notepad and can you show to me? I check. Because this way the class will not be interactive. I may call you someone. Pranati. Pranati, are you there?
Yes, ma'am.
Yeah. Pranati, you take a notebook, a notepad. Okay, so in the system, can you define, everyone can define the procedure, Lisp procedure for defining 5 less than x less than 10. X is between 5 and 10. You have to say x is greater than 5 but less than 10. How will you define a procedure? That is my question. Leaving, someone is leaving. Can you define? Someone raised hands, Nandini. The raised hands also not lowered. People are very busy. Okay, students. And this is a very simple answer in order to have a confidence that you are listening the class. That's all. How will you define a procedure? Okay, for a variable x, that x is less than 5, sorry, greater than 5 and less than 10. If someone knows, then you can raise your hands. Nandini is still raising hands. Okay, how people. Okay, students. Yeah, any one of you randomly, you can, any volunteers? Any volunteers, how to define a function?
Ma'am, can I tell me?
Yes, sure.
Actually, I written like define and let the function name be function and parameter is x and
Yes.
and the body I have kept two operations, ma'am. Like I have one operation is less than 5 and x and another one is less than x and 10. And for these two operations, I kept and.
And correct. Super, awesome answer. So, yeah, so it is all in your hand whether you are listening or not. So, just a minute. So, I can show you the answer for this. So, define what he told is very correct. Define range is the function and the variable is x. Okay, and then what is the notation? X is less than 5 and x is less than 10. That is a way of pronunciation, right? So there is a logical operator and is available, and relational operators greater than, less than, all are available. Okay, so if you take greater than and less than, is it a procedure? Yes or no? Greater than and less than you are using right here. Greater than x5, less than x10, where greater than and less than operators are called as a procedures. Yes or no? Yes.
Yes,
Why?
ma'am.
Because why? Because procedure means it will operate on all the arguments. Yes, all the arguments are necessary for in order to give a result of this predicate, right? Okay, so this is one simple example, and let's take another example. Define less than or equal to. See, in the previous case, I told that greater than, less than are built-in procedures. So by using a built-in procedure, can we define less than or equal to or greater than or equal to? Can we define? Yes. Okay. So greater than or equal to is a user-defined function. Actually, it is not available in the interpreter, but we are going to make use of greater and equal procedures. Okay, so define what we are going to define. So what is the procedure name? Greater than, equal to. This is the procedure name, and the formal arguments are x and y. If you look at the body section, x is greater than y or x is equal to y. So now in the body section, if you look at, this is the executable statement, and the executable statement is very primitive. This is a very primitive, all are primitive, right? Everything is known to the interpreter, how to evaluate greater, equal, or everything it knows, the interpreter knows. So we can write our higher concept, higher abstract by using the lower abstract, which is known to the interpreter. That's what I'm saying. Okay. So now, can you tell me, is there any other way of implementing the same thing? Any other way? The same thing, greater than or equal to x is greater than or equal to y, I have to define. Can you little think about what is the other alternate statement I can write?
We can use not statement, ma'am.
Not statement. Okay. How come not statement? Not of greater than or equal to? Not of greater than or equal to is not there.
Not of the whole or statement, and everything should be reversed. X is less than y, and it's
Okay.
yeah.
Instead, can I say less than x is less than y? Can I written like that? Only because it is greater than or equal to. The opposite is what? It is less
Ma'am,
than.
there is no or statement actually. Not of only x is less than y.
Okay. Okay. So now by using the not operator, we can also write just a minute, something like yeah. So by using the not operator, we can write x less than y. That also possible, right? Yeah. So there are alternatives available, but you have to be very careful. The body section should be a primitive one. Okay, it should be easily understandable by the Lisp interpreter. Okay, yeah. So let us take a few examples, and you have to tell me the answer. Define A3. So what is the value of A? It is 3. Okay. So define B plus A1. So what will happen? I am just going from the primitive to the little higher. So the next level. So what will happen? The Lisp interpreter will substitute to the value of A. What is the value of A? It is 3. 3 will be substituted here. 3 plus 1, 4. So B is 4. Okay, so there are environment created. What is meant by environment? Environment means in this particular language, it is like a memory. So the memory is created, or environment is created for the variable A and B, and in that environment, okay, the value 3 and 4 are associated for the names A and B. I can't say A and B are variable. For the names A and B, we have the values 3 and 4 associated. Okay, so now B is 4. Okay, keep in your mind. So next, if you look at this expression, what will happen? As we know that the Lisp is going to use the applicative order substitution model, right? There are two models, applicative order and a normal order, and we know thoroughly what it is. And applicative order is a very appropriate model used by the Lisp. Okay, that is, it will substitute the value and it will try to evaluate as soon as the value of the predicate or composition is known. Okay, so in this expression, what happens is here left to right it will perform. So plus A, B, and then something. So innermost bracket will be executed A into B. So what is the value of A? It is 3, 3 into 4, 3 into 4, 12. So 12 is substituted here, okay, as a third argument. And now if you look at plus, A is 3 and B is 4. 3 plus 4 plus 12. What is the answer? So what is the answer of this expression? 3 plus 4 plus 12. 7 plus 12, it is 19. I hope you are understanding, right? Let's look at A is 3 and B is 4 equal to your applying. So what is the value it will return? A is 3, B is actually there are two things. If you know what is this simple question and I'll ask to the final year student. And other cases you don't know, you will keep quiet. I don't know. Okay, so A is 3 and B is 4. 3. So 3 is equal to B, it is false. So what it will return? Hash F. It will return hash F. Okay, right. So by knowing this, let us go to the next higher level. I hope you understood already the syntax of if. What is the syntax of if? If the predicate, how much predicate? Till this. This bracket is ended here. Till this, it is a predicate. Okay. If the predicate is written in true, then B will be returned, else A will be returned. That is the meaning, right? Now tell me what is the value of this expression. So by continuing from the previous slide, A is 3 and B is 4. Just evaluate and tell me. A is 3, B is 4. I give you 1 minute.
4, ma'am.
It is going to return you B or A?
Yes, ma'am, it will return B.
It will return B. Okay, so if you take this one, 4 is greater than 3. Yeah, this is true. Okay, and if you look at here, 4 into 3, 12, and B is 4. So what is happening? B is less than 12. So both are true, right? So the result of the predicate is true. So that's why it will return B, right? So what is the value of B? B is 4. Yeah, you are right. Okay, let's move ahead. This is another fragment of code. So A equal to 4, return 6. That is the meaning, right? If B equal to 4, return this. Else, return this. So what is the value? So if you substitute here, 3 equal to 4, it is false. If it is false, it goes to the next predicate. 4 equal to 4, yes, true. If it is true, the corresponding expression will be validated. So what is this? 6 plus 7 plus 3. 6 plus 7 plus 3. So what is the answer?
16.
6 plus 7 plus 3, so 9, 16. Yes. Yeah, 16 will be the answer. Understood, right? So if it is a true, it will evaluate the expression and then come back it will return the value of the expression. It will not go to the next one. Okay, right. Take this one.
Ma'am?
Plus 2 if greater than B, A, B, A. So let's take in that part. If B is greater than A, if it is true, return B, otherwise return A. And that value will be one of the argument for plus procedure. Okay, let us look at 4 is greater than 3. It is true. If it is true, it is returning B. So that means 4. Right? So your answer is what?
6.
6, correct. So this if statement is returning B where B is 4. So 4 will be one of the argument for the plus. So 2 plus 4, it is 6. Very good. Okay. So Let's take this one. Okay, you take this one. There is define test xy. If x is equal to 0, return 0. Otherwise, it will return false. Okay. So now I'm going to call the test with 5,10 or whatever, 5,10. 5,10. So which one will be validated? Test of 5,10. So 5 is not equal to 0. Okay, so it will return y. What is that? 10 will be returned. Okay, so it's all very easy, nothing actually, nothing great at all. Okay, so let's take exercise from the book. I hope everyone has this file. I have it in Brave. Okay, so nowadays I started using Brave as a browser. Okay. Yeah, this is what we have seen. Yeah. Let us take an example. Exercise 1.3. Define a procedure that takes 3 numbers as arguments and return the sum of the squares of the 2 larger numbers. So how many abstractions you have to write? First of all, we need to have a square, right? A very primitive one. With the help of your square, you have to write another procedure. That procedure, what it takes 3 numbers and it returns sum of the squares of the 2 largest number. So that means you have to write the logic in order to find 2 larger number among 3 numbers. Will you please do? So you consider the argument as x, y, z. How will you find out the 2 largest numbers among 3 numbers? That too, you have to use the Lisp syntax.
Checking twice, man.
If you're writing in a small paper, you can show it, or otherwise you can write in a notepad. Can you show it, please, for others? You can share it. Any volunteers, anyone can do. Who responded? He can do. Students, you would like to show me the question? You have to define a procedure which takes 3 arguments, 3 numbers. You have to find out the squares of 2 largest number among 3. Quickly, within a fraction of time, final years, you have to solve it. Actually, this particular subsite full of mathematics, and you'll be learning the internal mechanism of the Lisp language, how it is working. By this, if you are learning the internal mechanism of 2-3 languages, you can define your own language. Okay, anyone volunteer? Any volunteers here? Please respond. After all, it is 2-3 lines of code. Who is willing to share the screen? Someone answered actually. See, we will have n number of problems, but you have to live in the present moment, right? You have to participate. No one else among 60 students.
Ma'am, you want the answer in
Yeah,
list
I
plan?
want the answer. Yeah, you can show to other students. Yes, Priyadarshan.
Like I'm not sure with the syntax, ma'am.
No problem, no problem. Let me see. Let me correct.
Like,
Wait.
can I say, ma'am?
Yeah, you please share it. I make. Can you raise your hand?
Can I write it in the form of ternary operators?
Yeah, whatever. Please raise your hand. I will just make you as a presenter.
No, ma'am. I will write it in the chat box. No.
Oh, okay, nice.
Can I write it in the form of ternary operator? Is that fine, ma'am?
Ternary operator. Where is the ternary operator in Lisp language so far? You can use cond, you can use if. That's what available. Only define with that.
Okay, ma'am. I'll convert this into that and I'll
Yeah,
come
yeah,
back.
yeah. Students, everyone, you can try. Given 3 numbers, you have to find out 2 largest number and then square of these 2 largest number. Any girl students? Krishna. Krishna, Charita, Gayatri. There are many bright students are available. They are not participating. So you can use if condition, if predicate, consequence, or um, that syntax if statement you can use. So in the next session, we will be installing the tool, and then we will do exercises. The questions will be like this only. You have to write a procedure. You have to show the answers. If you want, I can show the syntax of if, cond, etc. Whichever is applicable, you can. So look at the if. So this consequent can be another if. You take to compare 2 variables. Okay, So if it is true, go to the consequent. In the consequent, you can write another if statement, right? It's very difficult.
I tried something.
Yeah.
Let me put that photo in the chat.
Sure.
Ma'am, I put it on the chat window.
It is not available so far.
Could you please check in the post, channel post?
You want me to check in the post? Students, you can check in your post. I go to Teams. Why that chat is not coming? Yeah, I can see. Students, whether students, can you see the post? Can you see the post? Yeah, you just evaluate this whether it is true or is it correct or not. Where is the, see, you can't write like this, a square, you have to write a small procedure, define square, and there, here, whenever you want a square, you have to call the procedure, okay? So that is a mistake I found. So otherwise, uh, it should be a simplified code which is built on top of another abstract, okay? Right.
Yeah,
So according to you, if x is greater than y, then x is greater than z, then what is that? X is greater than y. Okay, x is greater than z. Okay, then something you have to return, right? What you are returning, which statement will be returned actually? I think it's a little complex. If you are writing from the primitive, go to the higher level. You want to explain? Yeah.
Yeah, ma'am. Here, if x is greater than y and x is greater than z, then the x is the highest one. And among y and z, we have to check which one is greater. If z is greater, then the squares of x and z will be added and returned.
Okay. Yes.
If here y is greater, then x and y will be returned.
Why that? Okay. Okay.
No, ma'am. Let me explain. Did you get it, ma'am?
Somewhat. You are adding here. For add, there is a plus, no? Why are you writing add?
Sorry.
Okay. So x square plus z square, and then you are coming here x square plus y square, x square. No, something wrong. Okay. So please try it out, and then in the next session, let us see that one. Okay. Okay, students. Please be into the system always. Okay. Try to learn, try to listen, because you have to spend exclusively some other time for a preparation. So that is not required if you are listening the class and doing some exercises and participating. That is a very good idea, right? Okay, thank you so much, and let's meet tomorrow. Yeah.
Thank you, ma'am.
Thank you.
Ma'am.
Yes.